Question 36 tells us that the polynomial y equals x squared plus bx plus c has x-intercepts at x equals -2 and x equals -6. Our job is to find the value of b. Consider a separate but related case. If we were given the polynomial y equals x squared plus 5x plus 6, and we were tasked with finding the x-intercepts of this polynomial, we would set the polynomial equal to 0, and then we would try to solve for x. We set the polynomial equal to 0 because by definition, x-intercepts have a y-coordinate of 0, so the y becomes a 0. We solve a quadratic equation like this one by either factoring or using the quadratic formula. When the polynomial is a nice one like this, we can factor rather than use the quadratic formula because it's faster to factor in most cases. From here, we set each factor equal to 0 individually and solve for x. This gives us solutions of -2 and -3. So how does this relate to the question at hand? Well, we have to use a similar process, but we need to work our way backward. In the case we just looked at, we ended up with the x-intercepts by starting with the polynomial. In the question we're given, we need to end up with the polynomial starting with the x-intercepts. If the x-intercepts are at -2 and -6, it tells us that when x is equal to -2, the entire polynomial is 0. And when x is equal to -6, the entire polynomial is 0. What we can say then is that if x equals -2, x plus 2 equals 0. If x is equal to -6, then x plus 6 equals 0. What we're doing here is working backward to find our factors. We now know one of the factors of the polynomial is x plus 2, the other factor is x plus 6. Multiplying these polynomials together, we get x squared plus 8x plus 12. If b is the coefficient on the x, then the value of b must be 8.